In the last video, we talked about one kind of problem where you would need to solve for a problem knowing that the function that you're trying to create is continuous. And the problem that we looked at was a problem about a function that was defined everywhere except for one point, and you needed to figure out what output to assign for that one missing input in order to make the function continuous at that point. In this case, we're going to look at a different type of problem, one where the left-hand branch and the right-hand branch are both continuous functions, and we need to find a value of k that's going to make them line up. All right, so let me hop over to the camera. Yeah. All right, there we go. So for instance, we've got two functions like this, and you can set a value of k for one of them that's going to make the left and right branches line up like this. All right, so the example that we've got here is that f of x is equal to 3x squared minus 4 if x is less than or equal to 1, and it's negative 4x minus 8k if x is greater than 1. All right, so this looks like a whole lot. But don't worry, let's go back to our definitions. So, does the limit exist? Well, we're not sure if the limit exists. We've got a left-hand limit and a right-hand limit at 1. And so we need to make sure that those two things are equal to each other. So let's think about that. What is the limit as x approaches 1 from the negative side of f of x? So looking at this function, if x is some number that's close to 1, but a little bit less than it, which one of these two rules are we going to apply? Well, if x is a little bit less than 1, then we're going to use this top rule, because this is the rule to apply when x is less than or equal to 1. So this would be the limit as x approaches 1 from the negative side of 3x squared minus 4. So can you evaluate this limit? Well, all you need to do is to use rule 1. So we're going to, if we just plug 1 into this, we're going to get 1 squared is equal to 1. And so 3 times 1 is 3 minus 4. So that's equal to negative 1. All right. What is the limit as x approaches 1 from the positive side of f of x? Well, if x is a little bit more than 1, we're going to use the second rule, because this is the rule that you use when x is more than 1. So this is the limit as x approaches 1 from the positive side of negative 4x minus 8k. And once again, we can just substitute 1 in for x, because that's going to give us an expression that is not undefined or indeterminate. So that's negative 4 times 1 minus 8k, which is equal to negative 4 minus 8k. All right, so that's very interesting. So our limit from the negative side is this, our limit from the positive side is this. Since we know that we want to choose a value of k that makes this function continuous at 1, what can we do with all of this information that's going to let us answer that question? Well, remember, in order for f to be continuous at 1, the limit at 1 has to exist. And in order for the limit at 1 to exist, the left and right hand limits have to be equal to each other. So we can just say the value of k that's going to make this true satisfies negative 1 is equal to negative 4 minus 8k. All right, and then we can solve this for k. Add 4 to both sides. We get 3 is equal to negative 8k. We divide both sides by negative 8, and we get that k is equal to negative 3/8. All right, so this is the value of the function that makes this function exist. All right, let's double check. Let's go on with the rest of our definition. So in order for f to be continuous at 1, the limit as x approaches 1 of f of x has to exist. So that's true. When k is equal to negative 3/8, then this is equal to negative 4 minus 8 times negative 3/8. The negatives cancel each other out. The 8s cancel each other out. You've got negative 4 plus 3, which is equal to negative 1. All right. So when we have this specific value of k, our limit from the negative side of negative 1 is equal to our limit from the positive side of negative 1. So the limit as x approaches 1 of f of x does exist. Does f of c exist? Yes, f does exist at 1. This was something we needed to be carefully sure of, but this top rule is applied when x is equal to 1, because this is saying x is less than or equal to 1. So f of 1 is equal to 3 times x squared minus 4, which is equal to 3 minus 4 is equal to negative 1. So once again, we see that the limit at 1 exists from the left and the right-hand side. F is defined at 1, and all three of these values are the same, which means that this function is continuous when we have this value k of negative 3/8. All right, so that seemed like it was a lot of work, but really all we had to do was just find a value of k that made the two parts of the piecewise function be the same value when x was equal to 1, which was that center point where the two meet. Okay, so hopefully that will give you enough of a start that you can get through that IXL assignment I-7, which is a problem that we are going to face quite a lot, and going forward, it's going to be something that we're